Let's solve one problem related to FIR filters. So related to actually linear phase. So length of an FIR filter is 9. If the filter has a linear phase, show that the following equation is satisfied. This is the equation which is given, has to be satisfied. So what you have been given is m is 9. Okay, m is 9 and it's a linear, the filter has a linear phase. That means what you have is tau equal to m minus 1 by 2, that's the first one, and h of n equal to h of m minus 1 minus n. These are the two conditions which are satisfied since it's a linear phase. This is the first condition, this is the second condition, right? So let's first get the tau equal to 9 minus 1 by 2, which is 4. Okay, so you can write this equation now, n equal to 0 to m minus 1 h of n into sine of omega into 4 minus omega n equal to 0. So it's like not equal to 0. So we have to prove what is this. Okay, so equal to, this will be equal to summation n equal to 0 to m minus 1 is 8 h of n into sine of omega. This is what I have. So this will be equal to, this is the condition which we have. So now I can expand this as h of 0, just plug it in. This is like sine of 4 omega plus h of 1 into sine of omega into 3. So that is like 3 omega, sine of 3 omega plus h of 2 into sine of 2 omega plus h of 3 into sine of omega plus h of 4 into sine of 0 omega plus h of 5 into sine of minus 1 omega plus h of 6 into sine of minus 2 omega plus h of 7 into sine of minus 3 omega plus h of 8 into sine of minus 4 omega. This is what you have. So I know that since this particular thing, right, is true, I know that h of 0 is same as h of 8, h of 1 is h of 7, and so on. So same way, h of 2 is equal to h of 6, h of 3 equal to h of 5. This is what you have. Okay, because of this particular condition, h of n equal to h of m minus 1 minus n. So I can now write this as h of 0 into sine of 4 omega plus this guy here. This will be clubbed with this guy, right? So I know that this is h of 8. So this is, there's a minus sign which will come out here, and this will become minus h of 8 into sine of 4 omega, right? Plus, let's take this guy now, h of 1 into sine of 3 omega minus h of 7 into sine of 3 omega plus h of 2 into sine of 2 omega minus h of 6 into sine of 2 omega plus h of 3 into sine of omega minus h of 5 into sine of omega. This is what you have, plus this guy goes to 0 anyway. This guy is going to 0. h of 4. So if you look at this, since h of 0 is same as h of 8, this will be cancelling to 0. H of 1 is same as h of 7, so this will be cancelling to 0. H of 2 will be cancelling to with h of 6, and h of 3 same as h of 5. So these guys will go to 0, so you will get a 0 here, right? So which means that this is proved. This particular equation is proved. Okay, let's start with that. Let's consider a problem which is consider a FIR filter with m equal to 11. Determine the magnitude response and show that the phase and group delays are constant. So what is given is m equal to 11. So we have to find out the magnitude response first of all, and also show that the phase delays and the group delays are constant, that is it is having a linear phase. So we know that m equal to 11, so h of z is n equal to 0 to m minus 1, h of n into z raised to minus n is the z transform of this FIR filter. This is the z transform of this FIR filter, which results in m, since m is 11, n equal to 0 to 10, h of n into z raised to minus n. So now one interesting property, since it's we are saying it's a FIR filter, it will have a linear phase, and that means the phase delay will be given as tau equal to m minus 1 by 2, which is 11 minus 1 by 2, which is 5. Same way, the other property is h of n will be equal to h of m minus 1 minus n, which means that it is having a symmetric, it's a symmetric filter. Okay, so since this property is true, h of n equal to h of m minus 1 minus n, where m is 11, h of 0 is equal to h of 10, h of 1 is equal to h of 9, h of 2 is equal to h of 8, h of 3 is equal to h of 7, and h of 4 is equal to h of 6. So this will be also true. So now you have h of z, which is h of 0 plus h of 1 into z raised to minus 1 plus h of 2 into z raised to minus 2 plus h of 3 into z raised to minus 3 plus h of 4 into z raised to minus 4 plus h of 5 into z raised to minus 5 plus h of 6 into z raised to minus 6 plus h of 7 into z raised to minus 7 plus h of 8 into z raised to minus 8 plus h of 9 into z raised to minus 9 plus h of 10 into z raised to minus 10. So this is what we have. So now I know that h of 0 is same as h of 10, h of 1 is same as h of 9, h of 2 is same as h of 8, h of 3 is same as h of 7, h of 4 is same as h of 6. So I can write this as I can take out the z raised to minus 5 here, z raised to minus 5 I can take out, and what I will get is h of 5 plus, okay, h of 0 will be clubbed together with h of 10, so h of 0 will be h of 0 into, since I have a z raised to minus 5 term outside and I don't have any z raised to coefficient here, so I need to balance it with z raised to 5 plus h of 10 is same as h of 0, so I can club this together and write this as z raised to minus 5, okay, plus h of 1 will be, since this is h of 1 is z raised to minus 1, z raised to minus 5 term is outside, so z raised to 4 will be inside, and h of 1 is same as h of 9, so z raised to minus 5 term is outside, so plus z raised to minus 4, okay, plus h of 2 into z raised to minus 3 plus z raised to plus 3 plus z raised to minus 3 plus h of 3 into z raised to 2 plus z raised to minus 2 plus h of 4 into z raised to 1 plus z raised to minus 1. So this is what I will have, okay. So now if you look at this closely, right, z raised to 4, z raised to minus 5, I can convert this into a frequency response, that is I can put z is equal to e raised to j omega and I'll get a Fourier transform which is called as the frequency response. frequency response is h of e raised to j omega, which is equal to e raised to minus 5 e raised to j minus j phi omega, and this will be multiplied with h of 5 plus h of 0 into e raised to j phi omega plus e raised to minus j phi omega plus h of 1 into e raised to j 4 omega plus e raised to minus j 4 omega plus h of 2 into e raised to j 2 omega plus e raised to minus j 2 omega plus h of 3, there is a 3 here, yeah, so h of 3 into e raised to j 2 omega plus e raised to minus j 2 omega plus h of 4 into e raised to j omega plus e raised to minus j omega. Okay, so what I get here is e raised to minus j phi omega into h of 0 plus h of 5 plus h of 0 into cos of, I just have to divide by 2 and multiply it by 2. What I'll get is a 2h of 0. So there will be a 2h of 0 into cos of phi omega plus 2h of 1 into cos of 4 omega plus 2h of 2 into cos of 3 omega plus 2h of 3 into cos of 2 omega plus 2h of 4 into cos of omega. So this is what I get. So if you look at this, right, this is all real part. This completely is real part multiplied by, it's basically of the form which is magnitude of omega into e raised to minus j phi omega. So this is my magnitude response. Okay, m of omega is my magnitude response, and my theta of omega, which is your phase response, theta of omega or phi of omega is phi minus phi omega. So I can write this as m of omega into e raised to j theta or phi of omega, which is, this is phi of omega is this is my frequency response, and m of omega is h of 5 plus 2 into h of 0 cos phi omega plus h of 1 into cos of 4 omega plus h of 2 into cos of 3 omega plus h of 3 into cos of 2 omega plus h of 4 into cos of omega. So this is what I get as magnitude response and the phase response. Now the phase delay tau p is minus phi of omega upon omega, which is phi of omega here is minus phi omega, so minus phi omega upon omega, so which is minus phi, which is your phase delay. Group delay is tau g, which is d minus d phi of omega upon d omega, so which is again d by d of this guy is so this is plus, yeah, this is plus, sorry, this is plus because minus, this is minus phi omega, right? So that becomes plus, so this is also plus 5. Okay, so what I get here is group delay and phase delay is 5.